Now that we've done our work with solving equations that have two variables, or x's and y's, with the two equations, we're going to take a look at making things a little bit more interesting and look at solving equations that have three variables. So x, y, and z now. And in order to do that, we're going to need three equations. So we're going to be solving for x, y, and z, three variables, and to do that, we're going to need three equations so that we can do that. I have steps listed here. You can see 1 through 5. I think it might be a little bit confusing and probably boring to read through the steps and then get started with the example. So what I'm going to do is jump into solving, and I will talk about each step from above as we proceed through the problem. So looking at the first step, we are going to pick two equations to eliminate one of the variables. And then we're going to be repeating this process. So similar to what we did when we had two equations and we were solving for x and y, we're going to have to take a minute and look at the equations and see which variable do we want to eliminate. Sometimes the information given will help us with that decision. We might see something that we think is quote unquote easy. Other times we'll have work to do and it will seem kind of random which we choose. So looking at our three equations here, and notice I've labeled them A, B, and C to help us keep track. What I see, you might see something different, but what I see when I look at these equations, in equation A, I have a negative 1z, that invisible coefficient of 1, and in equation B, I have a positive 1z. So my thought is I can just take those two equations as they are, A and B. So x plus 4y minus z equals 20. And then B is 3x plus 2y plus z equals 8. And I don't have to do any multiplication. I'm able to use the equations as given, and those z's will cancel or eliminate one another. So adding the rest of the equation, 4x plus 6y is equal to 28. So now I've eliminated z. I have to eliminate z in some combination of the other equations. So once you decide which variable you're going to eliminate, you have to stick with it. So looking again at my original equations, we used A and B. I'm going to use A and C now. So equation A is the x plus 4y minus z equals 20. And now equation C is 2x minus 3y plus 2z equals negative 16. Again, we have to eliminate the z. That's the decision we made. Looking at the z information in these equations, we have negative 1z and positive 2z. So they're not going to eliminate. We have a negative and a positive, but the coefficients are different. So in order to eliminate the z here, I'm going to multiply a by 2 to give us 2x plus 8y minus 2z is equal to 40. There's the new equation after being multiplied by 2. Because I have the positive 2z here, I don't have to do anything to equation C, and that will be 2x minus 3y plus 2z equals negative 16. So I have the two equations, and now negative 2z and positive 2z, the z is canceled, they eliminate, and we have to go on and add the rest of the equations. 2x and 2x is 4x. 8y minus 3y is positive 5y. And then 40 minus 16 is 24. So now, step 1 says work with the equations that you have, the three equations with three variables. work with different combinations of them to eliminate one of the variables. So now what we have are two equations with just two variables, x and y. So let me label this here. This was step 1. Moving on to step 2, what step 2 says is now solve these systems of two equations. In this case, we can use the elimination method that we've used above. If you want, we do have the substitution method that we looked at in the last section if you like that and want to use that. I'm going to continue with the elimination method, but you could do substitution if you wanted to. So now we have our two equations. Let me write these here. We have 4x plus 6y equals 28. And then we have 4x plus 5y equals 24. So here's, whoops, would help if I kept it on the screen. Here's our two equations. Looking at these, again, we want the coefficients to be the same. So I'm seeing a 4 and a 4 here, which is helpful. But in order to eliminate, one has to be positive and one negative. You could choose to make either one negative. I'm going to choose the top one. I'm going to multiply that by -1 to give negative 4x minus 6y equals negative 28. Now for the second equation, nothing has to be done. So we just rewrite it. And there's the two equations we're now going to add. Negative 4x and positive 4x, they eliminate. Negative 6y plus 5y is negative y, negative 1y. Negative 28 plus 24 is negative 4. So we have negative y equals negative 4. We need y to be positive. So multiplying both sides by -1, we get the answer y equals 4. So step 1, step 2, at the end of step 2, we have an answer, y equals 4, which brings us to our step 3. Step 3 up here says, now that you have a value for one of the variables, substitute that value into one of the two equations from step 2. So let's think about what this is saying to do. Over here, we have two equations with just two variables. So what we want to do here is we want to take this y equals 4 and put it into either one of these equations here to solve for x. So we're going to substitute y to find x. So in this particular problem, we're doing this because we found y. We're going to find x now. In other problems, you're going to be having different combinations of variables. But for this example, this is what we're going to do. So I'm going to use the first equation. Why? No reason. I'm just using the first equation. You might want to use the second, or maybe you agree with me, the first one is fine. So we have 4x plus 6y equals 28. So now 4x plus 6, and in place of that y, I'm going to put the 4 that we found from over here, equals 28. So let me do this. This y equals 4. I'm going to put it down in there just to make it clear what I'm doing. So 4x plus 24 equals 28. Solve this equation. I'm going to subtract 24 from both sides. 4x is equal to 4. Now divide, whoops, sorry about that again. Divide, having so much fun I forget to look up at the screen. Divide both sides by 4, and we get x equals 1. So now we have y equals 4, x equals 1. We have two of our three unknowns. Step 4. So going back up here, step 4 says use the two values you now have. So now we have 2, and substitute these into any one of the three original equations to solve for the third value. So let's take a look here. We have x and we have y. What we need to find is z. So we can go to any one. It doesn't matter, whichever one you like better, whichever one looks easier, friendlier, that's the one that you choose. So what we're going to do here is substitute x and y to find z. So now we have x and y, and we're going to substitute them to find z. So again, I'm going to use the first equation just because I can't justify that. For x plus 4y minus z equals 20. And we're going to substitute in. So x is 1, and plus 4, y is 4, z is the unknown we still need. And now we do the algebra. 4 times 4 is 16. And we are here. 1 plus 16, so we have 17 minus z is 20. Continuing on, minus z equals 3. And then we're really close, but we can't leave the variable in the negative form. So multiplying both sides of the equation by -1, I am going to get that z is equal to -3. So we have found now all three of our variables. So our answer is going to look like this. X is 1, y is 4, and z is -3. So x, y, and z. Be careful when you take your answers and write them in the parentheses. X must be first, y is in the middle, and then the z is in the last seat. If you mix up the order here, even though your numbers are the same, your answer will be considered incorrect. So let's go back here to this list here. First, you take of the three equations, you work with different combinations to eliminate one of your variables. Then you take your equations with two variables, work to eliminate another variable. Now you're down to one variable, and you can solve. When you solve, then you start to do your substitutions. You go up one level to the 2 by 2, and then you go up to the level with 3 by 3s to find your third part of the solution. Step 5 here, check your solutions. So once you get your answers, even though when you put it in My Lab Math and click, it'll tell you if you're right or wrong, you should be able to do the substitutions to check and make sure that your answer is correct. Again, I mentioned this point already. You should have 3 parts to your answer, X, Y, and Z, and make sure you're careful the order you list them in. And then this is important. This is a long process. It's long and it's tedious. It's multiplication, addition, again and again. Just because it's long does not mean it's impossible. You can do it. Make sure, even though you want to rush through it to get it done, please take your time, because what you'll find, unfortunately, is if you make one calculation error, your answers are going to be off and you're going to have to start from the beginning.